Wednesday? Sure. Okay, so in order to determine the difference quotient, we have this and we have this. What we don't have is this piece. Can anyone dictate how to create f of x plus h? Yeah, just dictate and I'll write it. Very good.
Squared plus 4x plus 2 plus 8.
Okay, can anyone give us f of x plus h?
X plus h squared plus
Very good. Awesome.
x plus h.
Very good. Very good. Excellent. Good. So how do we simplify this? Because we need to simplify it fully before we replace that. So first we have to square binomial. How many terms do we get when we square binomial? Yes, awesome. And they are? Excellent. Plus 4x, plus 4h, and plus 2. Now we have everything we need. I will replace this piece by all this. So it's x squared plus 2xh plus h squared plus 4x plus 4h plus 2. Now the negative sign gets distributed to all three terms. So it's minus x squared minus 4x and minus 2 divided by h. We know that two things have to happen here. One, all terms from the top that do not have h must go away. And eventually h in the denominator will go away. The final expression may still have, and will still have, I should say, will have h, but not this one. So negative x squared with positive x squared, negative 4x with positive 4x, negative 2 with positive 2. The remaining terms, 1, 2, 3, have h in common, and that's how the h from the denominator disappears, eventually. Can anyone give us the three terms that we have left in parentheses, so we can write them? Yes.
Plus 8.
Yes.
Oh, I'm sorry.
Plus 4.
Excellent. And that's the final simplified form.
That h by that x.
Say it again.
That h by that x.
You mean this one?
Like
This one?
the first 2x on the back. Yeah, isn't that h and then?
You took that out and you just
Thank you.
Sorry.
No problem.
Very slow.
You may see something I don't. There may be an error. I'd rather go back and check. Good. So we also wanted to look at a problem with a parallel line. Okay, so let's say give me a point, please, and give me the equation of a line. Any point you want.
3, 2.
And give me an equation of a line. Say it again. X equals 7. Can anyone give us an equation of a line?
Plus 3.
Say it again.
X equals 7.
7 plus 3.
3x.
Another x.
Y 1x plus 2.
Very good. So this is the equation of a line. And we are told that we're asked to find, actually, we're given the point and we are given the equation of a line, y equals x plus 2. And we're asked to find this equation, the equation of this line passing through this point and perpendicular to y equals x plus 2. Perfect. So I have a point which is not the y-intercept. So I'm thinking of y minus y1 equals the slope times x minus x1 in which the point is 3, 2. But I'm having a problem because I don't have the slope yet. But I look at this equation of the line that is perpendicular to the line that I'm trying to find. And I realize that the slope of this line is Perfect. Therefore, the slope of this line must be, if the slope of this line is 1, this must be -1. So that 1 times -1 equals -1. So therefore, we have everything. So we have the point and we have the slope. Remember, the product has to be -1. If this is -1/2, -1/2 times 1 will not equal -1. Better? Everyone? Okay, perfect. So then, as the next step, very good pick. I mean, by picking problems, you show me that you know what you're trying to. Yes, please, Dana? The product has to be -1. If one slope is 1, the other one must be -1 so that the product is -1. There is no other way. Or you remember it as m1 equals -1 over m2. I think the easiest thing to remember is that m1 times m2 equals -1. If this one is 1, m1 has to be -1 over 1, which is -1. It's up to you. Personally, I prefer that. It's easier even to say it. But it doesn't matter. It's up to you. So now we have everything. So this is y minus 2 equals -x minus 3. I distribute -1. And I move 2. So the equation of the line is -x plus 5. So this line is definitely going to pass through 3, 2. And it will definitely be perpendicular to this line, because the slope of this one is 1 and the other one is -1. -1 times 1 is -1.
Can we keep it from slope 1? Do we have to?
The problem will ask you to solve for y. Yeah. Good, very good questions. So let's go back and see if there is anything else that you would like to refresh your memory on. And I can't stress enough, I will do each and every test 10 times between now and the final exam. I'm not kidding. Only then I will say I'm on the right track. I acquired the skills. I reviewed everything. I'm going to ace this test. And you will. Final, I mean. Okay, is there anything else from this test 1 that you would like to go back to? This was the rate of change that we looked at. y2 minus y1 over x2 minus x1. Graphing of a piecewise defined function. Reading from a graph. Anything else from here? Rational equations.
How many questions are on the final exam?
About 20. It's a 2-hour test. Anything from this test, or you can look at test 2. Say it again. The rational equation. Very good. Excellent. So let's take a look. We have 1 over x minus 4. Minus 5 over x plus 2 equals 6 over x squared minus 2x minus 8. Yes, any questions? Yes, Vinny, go ahead. Anything? It's okay? Okay, so I recommend this method. You can use the method you prefer, of course. So in the next step, I will write that x cannot be 4 and x cannot be -2. Then I find the least common denominator to be the product of these two, of course. And then I need the adjustments for each of one. What is adjustment for the first one? At the top of the first one, what should I write? Very good. And then, of course, x minus 4. And this one is the same, so I shouldn't write anything. We'll just write 1. So then we have x plus 2. But now -5 gets distributed as -5x plus 20 and minus 6. You can change this into a proportion as we did before, or you can simply say a fraction is 0, only the numerator can be 0. Or should be 0 for the fraction to be 0. Or you just cross multiply. Either way, same thing. So then we have negative 4x, and this is 22 minus 6, which is positive 16. And then you get x equals 4. However, it's a problem. If you remember to state restrictions, then you will not make a mistake, because you still have to go and check against the restrictions. If you don't state restrictions and you write this as the final answer, I can't give full credit. You will get some credit for working this problem till this point, but if you consider this a solution, then you can get full credit. Is that clear? So I will write no solutions. I'll cross it out and say no, it's among the restrictions. It can be the solution. The denominator will be 0 for 1 or both, or 2 or 3, just 2 actually, when x is 4. It will be 0, so it's undefined. Good. So we go back to test 2 now, or not yet? Let's see if we want anything else from here. I'm sorry? Yeah, we did. Do you want to do another one, or do you want this one, or? I'm sorry? No, let's pick another. So just make one up.
Will it force us to use something?
Yes. Yes. One problem we'll have completing the square, yes. Sorry about that. So can anyone make one up? Any. Just make one up. Okay, so let's say x squared plus 14x equals 3. So I'll see you on Wednesday. If not, next Wednesday, don't forget. Please, do not forget to show up for the final exam. Okay, so the middle coefficient is 14. We divide that by 2. We get 7, and we square, and we get 49. So x squared plus 14x plus 49 equals 3 plus 49. Now all this has to be changed into a perfect square. And this, on the other side, we have 52. So what do we have on the left-hand side? Say it again. Of course. And now, very good. Excellent. So this is x plus 7 equals plus or minus the square root of 52. And 52 is 2 times 26, or 4 times 13. We have to simplify it. So this will be x equals negative 7 plus or minus 2, the square root of 13. And this is it. You're not required to do anything else here. Was this what we wanted?
Yes.
Okay, perfect. Anything else here? Let's go back and look at this. Completing the square. We solved this inequality and the absolute value too. Anything else from this test that you would like to review?
Did we
Yes,
already do 7?
the piecewise defined function? No, we did not. I don't think we did. Okay, so let's look at the piecewise defined function. You want to make one up, or you want this one?
No, let's do this.
Okay, let's do this one. So this is f of x. And we have 2x minus 4. 4x less than 1. And we have x squared plus 2 for x greater than or equal to 1. Okay. So obviously we have a piecewise defined function that has two pieces. This first interval is between negative infinity and 1, and the second interval is between 1 and infinity with a bracket. I will use these symbols under 1. Negative infinity to infinity, 0, 1. I will use this symbol to the left and this symbol to the right. And they're touching. There's no hole in between. Sometimes there is. I have extras from test 3. They made more copies than I requested. Is anyone interested in a hard copy of test 3? Go ahead. The one that I just returned. Well, Okay, so then I make myself a note and say, if between negative infinity and 1, make sure you use 2x minus 4. And obviously from 1 to infinity, make sure you use x squared plus 2. So I'm just plugging some numbers. When I plug in 0, I get negative 4. When I plug in 1, I get negative 2. On this side, when I plug in 1, I get 3. When I plug in 2, I get 6. That's really all I need. And now I'm ready to graph. Remember how to graph this. It's x squared up 2, not the entire function. I just want to picture this for a second, not the entire function, right? Just this. So it's x squared up 2. Okay. Just the portion of it, of course, not the whole thing. Okay, so from left to right, we have the first point, 0, negative 4. The next point is 1, comma, negative 2. And it's an open point because it's a parenthesis. 1, comma, negative 2 is an open point. I connect. I know it's a line. I connect, and this is it. So I finished with 2x minus 4. Now on the other side, 1, comma, 3, it's a full point, and 2, comma, 6, it's also a full point. And remember, the correct graph for x squared plus 2 should be x squared plus 2. But I can only graph this piece, nothing else. So the domain of this function is all real numbers. However, the range is from negative infinity to negative 2, union from 3 to infinity. As you see, there is a gap here between negative 2 and 3. Good. Do you think we can go back to test 2? Or do we still have anything here from test 1? Is this okay, everyone? Do not graph overlapping functions. So if you continue graphing this to the right, or if you continue graphing this to the left, the graph is incorrect. At any point in time, this is a function. If you graph this and you graph this, that's no longer going to be a function. By the vertical line test, it's not a function anymore. So it has to be a function. Cutting it with vertical lines, each vertical line has to cut the graph in one point. Okay, anything else you think from test 1? Heather, is this okay? Good refresher on that? Okay, so let's take a look at test 2. If you have a preference for version, please tell me and I'll go to that particular one. So here are the topics for test 2. So let's take a look. Solving an inequality that is not linear. It's polynomial or rational. Finding the horizontal asymptote or graphing a rational function. Graphing a polynomial function. Divide using log division. Finding the max, min, or x-intercepts. We just did that problem last time. A similar one. Find the domain. We did this problem, or a similar one. Finding function composition and evaluating it. Decomposing. We did that too. Write the equation of a circle, given the center and the radius. Write the equation of the circle. Find the inverse and graph them on the same coordinate system. Find the distance and the coordinates of the midpoint. We did this graph last time, step by step, with x and y intercepts and transformations. Does this equation represent the equation of a circle as the extra credit? Okay, which problem you would like to continue with? Any preference? The long division, very good. So let's take a look. So we're asked to divide x cubed minus x plus 1 by x plus 2. Let's do just that. Good pick. So x cubed minus x plus 1 divided by x plus 2. Okay. Any questions? Brian, go ahead. Any questions, please?
Let's just go take it to the top. And just do the whole thing. I'm good.
Okay. So we're dividing x cubed minus x and plus 1, and we know a term with x squared is missing, and both polynomials are in descending order. So our next question is x times what is x cubed, and the answer is x squared. Now I have to go back and distribute, change the sign, and write below like terms. So x squared times x is x cubed, but I subtract. X squared times 2 is 2x squared, but I have to subtract. So then negative 2x squared minus x. At the top, we will always write the correct sign. So x times what is negative 2x squared?
Negative 2x.
Very good. Negative 2x indeed. So negative 2x times x is negative 2x squared, but we have to change the sign. Negative 2x times positive 2 is negative 4x. We have to change the sign. And bring down the last in line. And this is the final question. X times what is 3x? Excellent. Very good. 3 times x is 3x, I subtract. 3 times 2 is 6, I subtract. So the remainder will be negative 5. So now I'm asking you, is x plus 2 a factor of x cubed minus x plus 1?
No.
No, because the is not 0. Very good. So then the answer would be x squared minus 2x plus 3 minus 5 over x plus 2. Is this okay, everyone? Good. So let's take a look and see what else we need to review.
Can we?
Yes?
Can we do the 3?
Number 3.
Oh, that's the case too.
Very good. So let's take a look. So let's take a look at number 3. What does number 3 say? Oh, graphing the polynomials. Perfect. Very good pick. So you want this one, or you want to pick another? This one. Perfect. So x to the 4th minus x squared. Immediately I will factor out x squared and then get this and continue factoring. Why I will always factor is because I will get the x-intercepts immediately. And I see how many x-intercepts will I have to get? Because the degree is 4. Very good. So when f of x is 0, I have 4 solutions. Can anyone dictate those 4 solutions? Two of them are x equals 0, one x1, and negative 1. So multiplicity 2, multiplicity 1, multiplicity 1. What happens at multiplicity 2? The function will? Yes. Remember x squared. That's a perfect example. What will the function do at multiplicity 1? Indeed. However, f of negative x stays as f of x. This will not change. This will not change. So the function is even. Please remember that. Okay, so let's create the table. Of course, the domain is negative infinity to infinity because it's polynomial. 0, 0, -1, 0, 1, 0. This is a turn, and this is a cross, and this is a cross. Now we have to establish the end behavior, and we're done. We can graph the function. But what is the end behavior? Since the degree is, so, and max 3 turns, not more. Since the degree is 4, it behaves like x squared. Since the leading coefficient is positive, x squared with a leading coefficient looks like this, so the end behavior would be, indeed, infinity to infinity. That's all we need. So we will plot -1, 0. We will plot 0, 0, and we will plot 1, 0. Bless you. And now we will perform what the chart, the table tells me. It tells me to come from positive infinity and cross. But I have to turn, because it turns again at 0, 0. I don't care for the rest of the table because I know it's symmetric with respect to the y-axis. So whatever I graphed on this side, I have to have a copy on this side. So I no longer need the table. So this is f of x, x to the 4th minus x squared. The only thing that I cannot determine by hand is finding the max min. So the maximum, the local maximum is at 0, 0, but the local min I can't determine. So we put it in, x to the 4th, and then minus x squared. And then we graph. I already have it here. I know the calculator is lying. Impossible. This is not the graph. Do not accept anything. And let's go and change the viewing window between -3 and 3. With a scale of 1, that's okay. And y minimum between -2 and 5 with a scale of 1. It's not good enough, so I'm going to say between a -2 and 2. It's crossing a -1, has to have a minimum. It comes back and turns at 0, 0. It comes down to a minimum and crosses at 1, 0 and going to infinity. So I know there is a minimum between -1 and 0. So second and calc. And I want a minimum which is 3 between -1 and 0. And the minimum is -0.71 at x equals -0.71 approximately, -0.25. And I will put it in either the table or the graph. So -0.71 comma -0.25. And this is this point. Can anyone give us the other point on the other side so we don't have to calculate anything?
0.7.
Very good. 0.71 comma -0.25. Very good. Thank you very much. That's all we needed. And that's it. So now if you want to determine the range, you can. You will say the range is between -0.25 and infinity. Because that's the absolute minimum of the function at -0.25 for y values. Okay, let's go back. Let's see what else we would like to review from this test. So inequalities. What type of rational function is this? Type 1, 2, or 3?
Type 2.
Very good, because the denominator has a higher degree than the numerator. For type 2, what is the horizontal asymptote? Always 0. Excellent. Very good. We did this problem in class together. Okay, we just did this one. We just did this one. This one we did last time, but if we want to, we can determine the maximum again. It's a quadratic function, -b over 2a. We did this last time. We did this last time, and this last time. And let's write the equation of a circle with center at -1, 3 and radius 2. So we are given center -1, 3, and the radius of 2. So can anyone tell us how to write the equation of this circle? Yes, so it's x minus -1, which is very good, plus,
X, Y minus 3.
very good, equals, indeed. Great job. And if we want to graph, we'll start with the center at -1, 3. And since the radius is 2, I want 2 units in all cardinal directions. So here it is. 2 east, west, north, south. Also, let's look at the extra credit here. For the extra credit, we had an equation, and we were asked, is this the equation of a circle? And the answer is, I have no clue. Let's copy it first. X squared plus 6x plus y squared minus 4y plus 9 equals 0. And let's identify, or first of all, let's discuss what we have to do here in order to see whether this is the equation of a circle or not. What should we do? Remember, this is the equation of a circle. If it doesn't have 2 completed squares, one with x and one with y, it may not be the equation of a circle. So in order to complete the square with x, what do I need? What should be the third term? 9. Luckily, it's right here. So it's x plus 3 squared. Plus. So these are all accounted for. So now let's look at y squared minus 4y. What does that need? On both sides, of course. Squared. 4. So this is y minus 4 minus y minus 4, y squared minus 4y plus 4, which is y minus 2 squared equals 4. 4 plus 0. So what is the center and what is the radius? So the center is -3, 2, and the radius is 2. Very good.